saying you need to study good. You are contradicting yourself. You said.
So, good morning. In the last class, we were discussing about the concept of the glacial landforms as well as river-related landform or fluvial landform. So, what is the difference between glacial landform and fluvial landform? Yes. Yeah, water movement. And what are the fluvial landforms we have discussed regarding in the upper course, middle course, and lower course?
Upper course.
River capture, waterfall, and gorges or canyons. Clear? In the middle course,
Meanders. Interlocking spur.
a river cliff. Yes, okay. Lagoon is in lower course. Lagoon as well as okay. Yeah. River cliff, lagoon, estuaries, oxbow lake, and deltas. These are floodplains. Deltas are floodplains only. So these are okay. What these are created in which course? These are created in the lower course. Clear? And then we discuss what is Noontak.
Top covering of the Indian polar region. That is
Not top.
snow will be covered at the
Bare rocks. The bare rocks, okay, is called as a Noontak, which is not covered in snow. While the at the mountain, when things are covered in the snow, it is called as a neve. It is called as a neve. Then we discuss what are the highland features and lowland. Glaciated highland and glaciated lowland.
Cody, covered,
Yeah, Bergschund. Then yes, U-shaped glacial trough, hanging valley, and moraines. Yes. And what are the lowland features? Glacial till, crag and tail, Roche mountain, then yeah, drumlin and esker. Drumlin and esker. So these are okay. What these are created in the lowland. So now we'll move on and we'll discuss the third one, which is arid or desert landforms. Okay, so now we'll move on to arid and desert landforms. So basically, what is a desert? What is a desert? Absolutely barren, where nothing grows, is called as a desert. Absolutely barren thing where nothing grows is called as what? Is called as a desert. However, there is a there is a very less true desert, because something grows even in deserts, so very less true deserts are there. In simple term, what is a desert? Absolutely barren region where nothing grows is called as a desert. And what you find is what you find is true deserts are very rare. True deserts are very rare. Why it is very rare? Because even in so give you homework to find out why most of the deserts are in this location. So we discussed this is what this is Tropic of Cancer. Yes, this is Tropic of Cancer, and this is Tropic of Capricorn. So we discuss most of deserts lies on the western margin. They lies on the western margin. So most of the desert lies on the western margin of what? Western margin of this, which is Tropic of Cancer and Tropic of Capricorn. Now, what is the reason why you find this desert over here? The one reason is in this region, there is a high pressure. In tropics region, whether Tropic of Cancer or Tropic of Capricorn, what you're going to find is high pressure. This high pressure is responsible for less rainfall. This high pressure is responsible for what? Less rainfall in this region. While equator have what? While equator have a low pressure, which is responsible for more rainfall. So equator has low pressure, which is responsible for more rainfall. So where we are seeing deserts, you are going to see, and you are going to see deserts over here. You are going to see deserts over here. So why you are finding deserts over here? One reason is that high pressure zone. It is a zone of high pressure. Both Tropic of Cancer and Tropic of Capricorn is a zone of high pressure, and zone of high pressure means less rainfall. Clear? When rainfall will happen? When rainfall will happen? When wind will go up? Wind will go up? As you go up, what will happen? Temperature will decline. So as you go up, what happens? Temperature declines. At mountains and etc., you have a lesser. So as you go up, temperature declines. So when wind will go up, what will happen? Wind will decline, and when temperature of wind will decline, whatever the vapor that is okay there, it will condense. It will condense, and it will form what? It will form cloud, and this cloud will then create what? Rainfall. Clear? So for rainfall to occur, wind need to go up. Okay, for rainfall to occur, wind need to go up. And when wind will go up? When there is a low pressure, because in low pressure only you see expansion is happening. When there is a high pressure, you are compressing things. Okay, when high pressure is there, you are trying to compress things. Low pressure means expansion is something that is okay taking place. High pressure and low pressure are the pressure at atmospheric pressure. Okay, there are atmospheric pressure. Wind will have a certain pressure. Clear? Like any substances. Okay, if I'm keeping this substances over here, what will happen? It will feel a pressure. Like that, wind also has a weight. No, wind is consisting of gases. These gases have a weight, so these gases will apply a what? A pressure. So when this pressure is low, then what will happen? Wind will go up. If this pressure is not there, then what will happen? They will remain as it is. Compression will take place over there. Clear? So whenever there is what? Whenever there is a low pressure, wind will go up and condensation will happen, rainfall will happen. So that's why equatorial region receives more rainfall. But when there is okay, what? When there is a high pressure, wind will not go up. When wind will not go up, then what will happen? No rainfall will takes place. So that's why in Tropic of Cancer and Tropic of Capricorn, this is a zone of what? This is a zone of high pressure. When this is a zone of high pressure, no rainfall is going to takes place. Clear? Any doubt regarding this particular thing? So remember that why equator, on the equator you will not find a desert. On equator you will not find a desert because it is a zone of what? Low pressure. On equator you don't find a desert because it is a zone of low pressure. While in Tropic of Cancer and Tropic of Capricorn, why you're going to find the desert? Because it's a zone of what? Zone of high pressure. Clear? Fine. Now secondly, we discussed most of the desert is what? Most of the desert are located on the western margin. They are not located on what? Eastern margin. They are not located on eastern margin. Most of the deserts are located on western margin. Why they are located on the western margin? The reason here behind this is okay, what? The reason behind this is a oceanic current. The reason behind this is a oceanic current. Why? Because at the western margin there is always a cold oceanic current flowing. On the western margin, which type of current is going to flow? Cold oceanic current. On the eastern margin, which type of current is going to flow? Oceanic current, warm oceanic current. Warm oceanic current. So on eastern margin, which type of current are there? Warm oceanic current. On western margin, which type of current are there? Cold oceanic current. Fine. Fine. Now, what is cold oceanic current and warm oceanic current? Whenever the current moves from where to where? Whenever the current moves from poles to the equator, what will happen? Cold oceanic current, because it is going to bring cold water from the poles towards the equator. Whenever the current will move from equator towards the pole, what will happen? It is going to be called as what? Warm oceanic current, because equator receives what? More sunlight. So whenever from here to here the current will move, it is going to be called as a warm oceanic current. Whenever from poles to equator the current is going to move, what will happen? It is going to be called as a cold oceanic current. Clear? So here at the western margin, always which type of oceanic current flows? Cold oceanic current. On the eastern side, which type of current is flowing? Warm oceanic current. Fine. Now, what will happen because of the cold oceanic current? If cold oceanic current are flowing, what will happen? The water will become what? Cold oceanic current is bringing the cold water. So cold water means what? Water will become what? Cold. Now the air that is in contact with the water, what will happen to this air? Air that is in contact with the water, what will happen to this air? They also becomes cold. If you hold ice in your hand, what will happen? What will happen to your hand? You'll also becomes cold. Why? Heat transfer takes place from the eye, from your hand to the eye, so your hand also becomes cold. So what will happen when water is cold? Air in contact will also becomes what? Cold. Air will also become cold. When air will also become cold, what will happen? Temperature of the air decrease and air will have a high pressure. When air will have a low pressure, when it rises up, warm current, warm thing, as we discussed, when you are heating something, what will happen? It will expand. So which type of air will expand? Warm air will expand. Which type of air will not expand? Cold air will not expand. So that's why this becomes what? This becomes cold current, cold air. Cold air means what? High pressure is going to develop. It is not going to expand. Clear? Any doubt regarding this one? So that is the reason why this area is not receiving rainfall. But when water is warm, what will happen? When water is warm, what will happen? Air will also become warm. When air becomes warm, air is going to what? Expand. When air is going to expand, what will happen? You'll see nothing but rainfall will happen. That is there. So that's why this side will receive rainfall, but this side will not receive what? Much of rainfall. So that's why more more deserts are lying on what? More deserts are lying on the western side. Clear? Yes.
So high pressure means there will be expansion.
High pressure, there will be compression. Compression means high pressure means you are compressing. Pressure when you are applying. Low pressure means what? Expansion. Okay. Fine. Any doubt regarding this one? So if question comes, why deserts are located on the western margin on the Tropic of Cancer or Tropic of Capricorn? So first thing you have to write, it is a zone of what? Tropics are the zone of high pressure, and second thing, cold oceanic current flows over here, which is making which is making this region much colder, and as a result no rainfall takes place. Clear? So these are the two reasons that you have to write. Clear?
So this desert is cold place or warm?
Desert is a warm place. There can be cold desert also, like Ladakh is a cold desert where nothing grows. Ladakh is also a cold desert. There are hot desert also, like Sahara is a hot desert, Thar is a hot desert. So those are the hot desert, depending upon at which location you are finding the desert. It can be cold desert also, it can be hot desert also. Fine. So what is the reason why deserts are located on the western margin? What is the reason why deserts are located on the western margin? Because of cold oceanic current. And why the deserts are located only on the tropics? They are located on the tropics because tropics are the zone of high pressure. Tropics are the zone of high pressure. Clear? So these 2 points you have to keep in mind. Fine. So deserts, I'll just write it. Deserts are located near tropics. Tropics, as it is a zone of high pressure, and they are found on western side of continent because of cold oceanic current. They are found on the western side of continent because of what? Cold oceanic current. Fine. These 2 points you keep in mind. Deserts are always located on near the tropics. Why? Because tropics is a zone of high pressure. Second, they are found on the western side of the continent. Why they are found on the western side of the continent? Because of cold oceanic current. Fine. Fine. Now, So now, when you look at this figure, what you are finding here on the western margin, which desert is located? This western margin, which desert is located? Sahara Desert. Here, what desert you are finding? Namib Desert and Kalahari Desert. Clear? Here, what desert you are finding? Atacama Desert. Here, what desert you are finding? Sonoran Desert, Mojave Desert, Chihuahuan Desert. These are the desert that you are finding on what? On nothing but okay, western margin. Here, what you are finding? Thar Desert. Here, what you are finding? Sandy, Gibson, Great Victoria, Simpson Desert. All these are lying on the western side. Okay, that is okay there. Clear? So note down the name of these desert. Note down the name of these desert. In examination, you will get okay name of the desert and the country which they are located. So first you start with this. Write down Mojave and Sonoran and Chihuahuan Desert. You write down these three and write down it lies in North America. That is in USA and Mexico. So write down this Mojave, Sonoran and Chihuahuan Desert and write down here North America. Here mention you USA and Mexico. Fine.
These deserts are along mountains.
Not necessarily they are in along mountains. Andes are there. Okay, here you can find mountains. Here you don't find any much mountains over there. Yeah, Sierra Nevada. Okay, this is there. Clear? So that is created. Some mountains, some deserts are created on the other side of the mountain. Okay, because rainfall is less. Why rainfall is less? We'll take up in climatology. Clear? So some deserts you may find along the mountain, but not all deserts. Okay, you'll find like Thar Desert. You'll find okay Aravalli. It is not on the other side of Aravalli, rather on the this side of Aravalli. Okay. So just note down the name, desert name. Write down Mojave Desert, Sonoran Desert, Chihuahuan Desert. Here you mention USA, Mexico. Then you write down Atacama Desert. Write down here Southern America. Patagonian Desert. You write down Argentina. Argentina. Then Namib and Kalahari Desert. Here you mention Namibia and South Africa. Namibia and South Africa. Namib and Kalahari Desert. Mention about Namibia and South Africa. Clear? Next, Sahara you can mention. Sahara you can mention and write here Western Africa. Western and North Africa you mention. Western and North Africa. Western and North Africa. Then mention about Australian desert. Mention all these four deserts: Great Sandy, Gibson, Victoria, and Simpson. Mention that all those four lies in Australia. Clear? On the eastern side, yeah, this here warm current. This side is cold current. That's why you're finding desert. This side is warm current, no? Which one?
And between Australia and separate, they will be night ocean currents.
Ocean current means water movement.
Means this pool is Pacific or something.
This is Indian Ocean.
It should be completely the course of warmer.
No, not warmer should be present. What happening is okay here. What is there? Antarctica is there, no? The polar region. So as we discussed, from poles, if current are going to come, then what will happen? Colder current. From the equator, if the current are going, then what will happen? Warmer current. Clear? So equator receives more sunlight. So from here, when current are moving like this, it is going to be warmer. From here, when current comes like, it is going to be colder. Then after mentioning, you mention about Arabian desert Arabian Desert, you have mentioned about Saudi Arabia and other countries. Saudi Arabia, UAE, all those countries comes under Arabian Desert. Then you can mention about Syrian Desert. Here you mention Thar. Thar is India. Then Taklamakan, Gobi. These mention as China. Taklamakan and Gobi, you mention this as a China. Fine. Clear? So these type of questions you are going to get in the case of examination. So one of the questions that you will find, which pair is correctly matched?
Suppose
Fourth is correctly matched. Anyone else?
Second option.
Second is correctly matched. Okay. Anyone else?
suppose is not
Fourth is not correctly matched. Okay. So the first is Syrian Desert. Syrian Desert lies where? It lies in the Syria. Syria lies in Asia. It is an Asian country. It is not part of Africa. Clear? So it is in Asian country. Victorian Desert, yes, Australia. This is correct. Simpson again lies in Australia. We discussed in USA which desert lies? Sonoran Desert. So just now we discussed which desert lies in USA? Sonoran and Mojave Desert. Those lies in case of USA. So this is wrongly matched. Patagonian Desert, we have just now discussed, it lies in Argentina. It lies in Argentina. So this is wrongly matched. So like this, okay, you are going to get question in the case of examination. Name of the desert, countries in which they are located. Clear? So remember that most of these deserts, discuss where it is located. Most of these deserts, where it is located on the western margin. They are being located on the western margin. They are being located in which region? Tropics. You can see Tropic of Cancer passes through like this, and Tropic of Capricorn is okay what? Passing like this. Okay, that is okay there. So most of deserts are located on the tropics. Why tropics? Because tropics is a zone of high pressure. And second thing is what? Okay, they are lying on the western margin due to cold oceanic current. Fine. Fine. So now remember this particular part. So this is what it is writing over there. Confined within, most of the desert are confined between which latitude? 15 to 30 degree latitude of north and south of equator. Hot desert, Sahara, Arabian, Iranian, Thar, Kalahari, Namib, Atacama, all these names, okay, we have discussed. And there are certain deserts which are not found on the side or the margins. Like we discussed, most of the desert are found on the margins, but there are certain deserts which are found in the interior, like Gobi Desert, which lies in China. So it is an interior desert, so that is called as a continental desert, not coastal desert. So most of these are coastal desert, lies in coastal region, but this is a continental desert. So just okay, note this particular point, that most of the hot desert lies between 15 to 30 degree latitude. Fine. Now, deserts also we can classify into different type depending upon what we find in desert. If we are finding rocks, means rock only are present in desert, we are going to call it as a rocky desert. If the sands are being found in desert, it is going to be called as sandy deserts. So depending upon what? Depending upon the situation, what we are finding in the desert can be classified into different types also. Fine. So the first thing that you are finding over here is 5 distinct type of nothing but landscape. 5 different type of deserts are there. The first type of desert we classify as a rocky desert. Rocky desert are also known by the name Hamada. So rocky desert are also known by the name Hamada. These rocky desert are also referred as a Hamada. Clear? Example of rocky desert is which type of desert? Sahara desert. Sahara desert is an example of which type of desert? Rocky desert. So here you will find largely barren, hard, rocky plateau with very little sand. So when you find rocks, very little sands and etc., such type of deserts are called as what? Rocky deserts or Hamada. And why this sands is not there? Because of this process which is called as a deflation. Why sands are not there? Because of this process called as a deflation. What is deflation? As we discussed, let's say like this sand is there on the surface. When wind is moving, let's say wind is moving, wind will pick up these material and will take up what? Will take up these material to some other location. As a result, the sands are not present and this process is referred as what? This process is referred as a deflation process. This process is referred as a deflation process. Clear? So why sands are not present? As wind will pick up the sands and take the sands to some other location that is there, and this process is referred as what? This process is referred as a deflation. So you can see fine grained powder are taken away in suspension and the sand is removed through saltation. Clear? So this is the reason why you see what? Why you see the rocky desert do not have much of sands. Fine. So the first type of desert we have classified is which type of desert? Hamada or rocky desert. So in rocky desert, only rocks are going to be present. There will not be any presence of what? There will not be any presence of sand. Why sand presence is not there? Because wind will take away sand from one location to another location. And this is called as what? This is called as a deflation. This process is referred as a deflation. Clear? Now the second, you'll find which type, you'll see figure. If you see figure, you'll find this type. So you'll find this type of desert, rocky desert. So you'll find this type of rocks, rocky desert. So not much of sands you'll find, nothing vegetations you're going to find in these deserts. Such type of deserts are going to be called as a Hamada or rocky desert. The second type of desert that you find is a reg or stony desert. So stony deserts are also referred by the name reg. So stony desert are referred by the name reg. And what happens here is, you'll find why you'll find stone, because stones are bigger in nature. Wind cannot move stone from one location to other location. That's why you're going to find what? You're going to find these stones. So it is composed of extensive sheet of angular pebbles and gravel, which the winds are not able to blow off. Since wind are not able to take it from one location to another location, It is called as a reg or stony desert.
So this scientific
Yeah.
whole together thing.
Yeah, till what? No, previous also and this also, both. Fine. Now, which type of okay, the stony desert you are finding? This type of stony desert. Large stones you're gonna find in the desert, and this type of deserts are referred as which type? So stony desert or a red desert. Clear? The third type is okay. What? The third type is erg or sandy desert. So sandy deserts are also known by the name erg. So wind deposit the sands in the desert. Wind deposit the sands in the desert. An example of this type of desert can be your Libyan desert. In Libyan desert, you're going to find sand deposition. So this type of desert example is Libyan desert. So wind is moving, wind is taking sand and depositing the sand in this location, and that's why lot amount of sands are found in this desert. That's why it is referred as a sandy desert. Fine. And if you see the figure, this type of figure that you're gonna see, and these deserts are referred as which type of desert? Sandy desert. So Hamada means rocky desert. The erg means what? Sandy desert, and reg means what? Stony desert. So those three type of desert. Next, you find something called this type of figure. Now here you are not finding something very proper. Grounds, if you see, it is what? Up and down, up and down. You can see some up, some down, some up, some downs. Okay, you'll find up, down, up, down. It is not proper smooth thing that you are finding, and that's why this is referred as a badlands. These are referred as what? These are referred as a badlands. So it is a type of dry terrain. Dry terrain means generally desert type. It is a type of dry terrain where softer sedimentary rocks and clay-rich soils have been extensively eroded. So it is a dry terrain where softer rocks and sedimentary rocks are extensively eroded by the wind, and that's why you see different different type of nothing but the levels in the desert. So they are characterized by steep slopes, minimal vegetations, lack of substantial regolith, and high drainage density. So those are the characteristic of badlands. Okay. So steep slopes, you are finding this type. Steep slopes you are finding. Secondary is what? Minimum vegetation, because desert is there, so not much vegetation you're going to find. Lack of substantial regolith. Regolith is kind of a loose soil. So you don't find much of a regolith, loose soils over here. And lastly, high drainage density. More water can go inside. That's why drainage density is high. So these are referred as what? These are referred as a badlands. Fine. Now the last type that you find is what? Last type that you find is a desert mountains. The desert that are found on the mountains are referred as what? Are referred as a mountain desert. So the desert that are found on the mountains are referred as what? Are referred as a mountain desert. Like we discussed Ladakh region, it is referred as a cold desert region. So desert found on the mountains. Fine. So you'll find like this, okay? So nothing grows on the mountains. You'll find nothing grows like this. So this type of deserts are called as a deserts mountain. Fine. So remember that always deserts are found where? In the 15 to 30 degree latitude. They are found over there. And what is the reason? It is a zone of high pressure. And secondly, what will happen? Cold oceanic currents are flowing. 5 different type of deserts are there. What are the 5 different type of deserts? Hamada, that is rocky desert. Erg or sandy desert, reg or stony desert, badland, and desert mountain. Those are the 5 types of desert that you are finding. And also the important thing that you have to keep in mind with regard to desert is their distribution across, okay, what? Across the map. So remember, Sonoran desert is where lying, Mojave desert is where lying, Namib desert is where lying. So those type of questions will come in the case of prelims part. Fine. So if you look at can you answer 21?
So cold ocean currents and high pressure wind.
Yeah, zone of high pressure. So you have to write that 20 to 30 degree northern latitude is a zone of what? High pressure. When there will be high pressure, there will be what? Lesser rainfall. And why they are found on the western side of the continent? They are found on the western side of the continent because of cold oceanic current. So that is okay. What the question has been asked in the case of examinations. Clear? So this point you have to keep in mind with regard to desert. Fine.
So in this question,
Yes.
can you draw a diagram?
Yes. Okay. Yes. You have to diagram. You have to explain, okay, because question is asking regarding northern hemisphere. So what are the desert you are finding in the northern hemisphere? So you have to explain about what? Mojave and Sonoran, which is found in Northern America. Then you have to explain about what? The Arabian desert, Syrian deserts over there, Thar deserts. Those deserts you have to explain by making a diagram because question is mentioning about northern hemisphere. Fine?
So
Yes.
we have to write in 100 words. So can you just tell how to do that? That question will be.
This question.
Yes, sir.
So you have to first write introduction, no? So first you have to write introduction, and I'll just open the question also first. Now, what the question is saying, major hot desert in northern hemisphere. So major hot desert in northern hemisphere are located in 20 to 30 degree on the western side of the continent. Why? Clear? So first you have to introduce that deserts are what? Introduction, what you'll write? Deserts are barren or barren surface where nothing grows, and can be classified into hot or cold desert, So first you have to explain what is hot desert. So for that you have to write what is a desert, then you have to explain the desert can be classified into hot and cold deserts. So hot deserts are those which are located at which latitude? Which are located in the tropics region. Hot deserts are those deserts which are located in tropic region, while the cold deserts are those deserts which are located in what? Polar region or mountain region, highland region. Okay, so the cold deserts are those deserts which are located in a polar region or in mountain or highland region. Those deserts are going to be what? Cold deserts. So that you have to write in the case of introduction. The deserts are what? Barren, where nothing grows, and they can be classified into hot and cold desert. Hot deserts are one which lies between 20 to 30 degree, while the cold deserts are something that are lying generally in what? Generally in the polar or highland region. Fine. Now then you have to write the reason in body part, the reason behind the reason behind the hot desert located in 20 to 30 degree latitude. Located in 20 to 30 degree latitude are point number one, that this zone 20 to 30 degree zone, latitudinal zone is a zone of high pressure. 20 to 30 degree latitudinal zone is what? Is a zone of high pressure, and because of high pressure, air subside and not rises up. Causing no or lesser rainfall due to anticyclonic conditions. You can mention regarding this term, due to anticyclonic conditions. So 20 to 30 degree latitudinal zone is a zone of high pressure. Because of high pressure, as we discussed, if low pressure is there, wind rise up. If high pressure is there, then what will happen? Wind will subside, and as a result, what will happen? You'll see the wind subside over here. That's why no or lesser rainfall, causing what? Causing which type of condition? Anticyclonic. Cyclonic condition means rainfall will happen. Anticyclonic means no rainfall will happen. Clear? So this you have to write as a first point. Clear? The second point, what you'll write? Second point, the western side of the continent experiences cold oceanic current, which makes water colder, thereby making air in contact with the water, also colder. Air in contact with the water also colder. Clear? Also colder. As a result, the colder winds subside and do not create much rainfall. Fine. these are the 2 points you have to mention, the first point as well as nothing but okay second point. So the first point you have written that why they are located in 20 to 30 degree latitude, and second point you have explained why they are located on the western side of the continent. Fine.
So also, when the wind is cold, will it affect the evaporation rate?
Yes, it will affect the evaporation rate.
If we add to it 200 once, I can add that to
You can also add that point, but that is already understood. Okay, but when colder wind are okay subsiding, why colder wind do not have a much of moisture. Hotter wind has what? More moisture. Okay, so that is okay there. Clear? So colder wind is subsiding means what? Okay, this whatever the moisture is there will remain at the surface. It is not going up. When it is not going to up, okay, what will happen? No condensation. Okay, so even if okay colder wind will have more moisture, but if it is subsiding, okay, then it will not be having what any type of rainfall. So rainfall happens when wind will go up. Even a small amount of okay moisture is present. If the wind will go up, then what will happen? Rainfall will happen. Fine. So that is the reason why you see nothing but okay this type of okay thing you have to write. Then you have to write, make a diagram, because it is talking about which desert, which side, northern hemisphere. Make a diagram and explain, make a map and explain northern hemisphere, which are the deserts that are lying. Clear? And then conclude your answers. Fine. Okay, fine. Conclusion you can write. I'll just erase this. So conclusion, you can write the hot desert like Thar, comma, you can mention about Sonoran, Arabian, etc. are located in this zone due to oceanic current movement as well as the presence of subtropical high pressure belt existing in this region. So whatever you have written, you have summarized that in the conclusion part. Hot desert like Thar, Suriname, Arabian, etc. are located in the zone due to oceanic current movement and due to formation of subtropical high pressure belt existing in this region. Fine.
Sir, is it fine if the answer is less than 200 words?
Yeah, fine. The answer is less than 200 words. Maximum you can go is 200 words.
And if it is more than 200,
Then you'll face a problem. Let's say 220 words is there, 10, 15 words, okay, not a problem. But if it is going beyond that, what will happen? Then you'll have, okay, what? You'll have problem in attempting other questions. And also, if word limit are too exceeding, let's say sometimes, okay, question is mentioning the limit of 200 words. If you have a 300 words or 350 words if you are writing, then there is a penalty marks also. Then there is a penalty marks also in the mains examination. Clear? So if you are not following the instructions, then what will happen? A penalty marks will be nothing but okay also added in the examinations. Clear? So in the prelims you have a negative marking. If you are giving a wrong answer, then what will happen? Negative marking will be there. Right answers you will get the correct marks. But in the mains examination you also have okay which type of marks? Penalty marks. If you are okay doing anything okay which is not given in the instruction, like let's say if you are mentioning your name, writing something like some symbols you are writing, making some symbols which is not required, then okay in such case okay what will happen? Penalty marks are there. Why? Because the examiner do not know your identity. Okay, if you are trying to make your religious identity or something you trying to reveal something to the examiner, or you are trying mentioning, like let's say letter writing has come, you are ending your faithfully mentioning your name and etc. That is okay there. Rather than mentioning your name, you have to write ABC or something XYZ you have to mention. So anyway, you should not reveal your identity to the examiners. That is okay there. So that is okay. If you are revealing in any way, that also is what penalty marks is going to be there. Clear? So penalty marks are kept for these if you are violating any kind of instructions. That is okay there. Fine. Any doubt regarding this one? So now we are coming to the arid erosion, how the wind erodes, because we were talking about agent of erosion, and we discussed where the wind is more dominant. Wind is more dominant in a desert region. So that's why we have discussed type of deserts also, where the wind are something that are more dominating. Clear? So what is the reason behind arid erosion? It says insufficient rainfall, rapid rate of evaporation, weathering, and action of wind. So these four together combines to form what? These together combines to form what we called as a arid. Arid means desert. Desert. Why erosion happens? So let's say it is easier to erode. It is easier to erode soil which are soil which are not wet, or soil which are more wet.
Not right.
Not wet. Why?
So because they do not have weight to carry. For
Yeah. When soils are not wet, they are less heavy. As a result, wind can carry them. If the soils are wet, then what will happen? They will become more heavy and winds will not be able to carry them. So if there is insufficient rainfall, if there is a more evaporation, soil will lose more moisture, or things will lose more moisture. More moisture means it is easier for the wind to erode. It is easier for the wind to erode. So that's why insufficient rainfall, rapid rate of evaporation, and weathering of rocks, like we discussed. In which type of weathering dominates in desert region? Salt weathering. Yes. Okay. So we discussed which type of weathering generally dominate in the desert region. Salt weathering. Clear? So weathering will happen. And finally, the winds are something that are moving. So winds will carry these particular things. So these are what? These four are the reasons responsible for what? Responsible for arid erosion. Fine. Now, there are three things what you are finding. Action of wind is in desert, deflation, abrasion, and accretion. There are three things that you are finding. So wind are going to what? Wind are going to erode things by three processes: deflation, abrasion, and attrition. Last class we discussed attrition. What is attrition? What is attrition? Last class we discussed this term attrition. What this term attrition means? So we discussed when river will move. Last class we discussed when rivers are moving, rivers will carry the sediments. These sediments will collide with each other. When they collide with each other, what will happen? They will be further broken down. This process is referred as what? This process is referred as a attrition process. So when wind is also carrying particle, these particle will collide with each other. When this particle will collide with each other, what will happen? Attrition will happen. So that is what we called as a attrition process. Deflation. What is deflation? We discussed wind picking up the particle and taking away to another location. That is called as what? Deflation. And the third is abrasion. What is abrasion? Now let's say this is a rock. Let's say this is a rock that is there in what? There in the desert region. This is a rock that is there in the desert region. Now the wind is blowing like this. Wind is blowing like this. We discussed wind is going to carry what? Carry the particles. Because of deflation process, wind is going to carry the particle. Now these particles are now colliding with what? Colliding with these rocks. When these particles are colliding with themselves, then it is called as what? Attrition. But when these particles are colliding with the rocks, they are going to erode the rocks, and this process is referred as what? Abrasion process. Clear? So when they are colliding amongst themselves, it is called as attrition. But when these particles collide with the rocks, then it is going to be called as which process? Abrasion process. Fine. So three things are there: deflation, abrasion, and attrition. Deflation means what? Wind picking up the particles and moving away. This is what we call as a deflation process. Second is what? Abrasion. What is abrasion? Abrasion is basically taking away what? Taking away nothing but okay, these particular particles and colliding with the rocks and etc. which are present in the desert. Then these rocks will get eroded. This is called as a abrasion process. And attrition means when they themselves will collide with each other, breaking will happen due to friction. And this is called as what? This is called as a attrition process. So these are the three ways in which you see what? In which you see wind are performing certain action in desert region. Fine. Now, so this is what definition it is talking about. What is a deflation? It involves lifting and blowing away loose material from the ground. So deflation process is what? When wind is lifting away material and moving away, then it is called as a deflation. Now, there is one thing you have to keep in mind. Now, let's say this is okay, what? This is okay, the surface. Now, wind is picking up the particle and taking this particle away. This is what we call as which process? Deflation process. Now, how much level up these particles will be picked by the wind? At what height you're gonna see these particles are going to be picked up by the wind? It will depend upon the weight of what? Particles. Any other thing? Yes, it will depend upon the weight. Also, since okay, the wind is doing it against the gravity, what is happening? Gravity is trying to attract everything. Now wind is picking up and moving things away against what? Against nothing but okay, gravity. As a result, wind will not take these particles to a greater height. Most of these particles will be in the lower part of the wind only, not in the upper part of the wind, because wind has to lift it against what? Against the gravity. So when they are going to collide with the rocks, as we discuss abrasion process, they are going to collide with the rocks. They are going to erode which part of the rocks? Lower part or upper part? Lower part. Yes. Okay. Since more particles are concentrated in the lower part, so that's why they are going to erode the lower part of the rock and not erode the upper part of the rocks. Clear? So over a period of time, you'll see rocks will be like this. This rocks, okay, which is like this currently. This rocks will turn into like this. Lower part will get eroded and the upper part will remain at it as it is. Okay, so this is happening due to what? This is happening due to the wind not able to pick up okay much of the particle to the greater height, because it has to move out against what? Against the gravity. Clear? The second process we discuss is what? Abrasion process. It is a sand blasting of rock surface. So whatever the sands wind is picking up, when it is okay blasting the rock surface, then they are called as what? They are called as a abrasion process. And we discuss where the abrasion will be more effective, at the base of the rock, whereas where the more amount of the particles wind are able to carry. So that's why abrasion will be more at the base of rock. Fine. So that's why we discuss which type of okay rocks you're gonna see. Mushroom shaped rock. That's why you'll find which type of rock? Mushroom shaped rocks. So this rocks which is like this will change into like this, because abrasion is happening over here. Abrasion is happening on this side. Fine. So deflation is what? Wind picking up and moving away. This process is referred as a deflation. Abrasion is what? Abrasion is wind particles blasting or eroding the rocks. That is called as what? That is called as a abrasion process. Fine. Now the third, as we discussed, is which process? Attrition process. So what is attrition? It is when wind particles roll against one another, collide with themselves only, then it is going to be called as what? It is going to be called as a attrition process. Clear? So when wind particles roll against one another in collision, then they are reduced in size, and this reduced particles are referred as what? This reduced particles are referred as attrition process. Clear? So remember we discussed in the rivers what process is dominating. In rivers, what process is dominating? Corrosion. Yes. In case of glacial, what process is dominating? Plucking. Yes. And in case of wind, what is dominating? Deflation and abrasion. So in case of wind, what is dominating? Deflation and abrasion. This is dominating in the case of wind. Fine. Now we are coming up with the landforms. So when wind erodes, what are the landforms it is going to make? So you can see rock pedestal or mushroom rock. Second is Jugan. The third is Yardan. The fourth is Mesas and Buttes. Fifth is Inselberg. And lastly, Ventifact and Recanter. These are the landforms that are made due to wind erosion. Rock pedestal or mushroom rock. Second is what? Jugan. The third is Yardan. The fourth is Mesas and Buttes. Fifth is Inselberg. And last is Ventifact or Recanter. These are the landforms which is made by wind erosion. So just now we discussed if the wind are going to erode more at the base, so just now we discussed wind are eroding the rocks more at the base, and as a result the rock is becoming like this. This type of rock is referred as which rock? Mushroom rock. So that is what mushroom rock is all about. You can see this is how you're going to find mushroom rock. So you see wind has, because of erosion at the bottom, you'll see it has become tapered, but upper part remain as it is. That is called as the mushroom rock. Or you'll also find like this. So this is how you are finding mushroom rock. That is there. Clear? So the first type of thing that the wind are making is what we call as a rock pedestal or mushroom rock. So what is mushroom rock? It is a naturally occurring rock whose shape resembles what? Whose shape resembles a mushroom. And why it is found in desert? Because of abrasion process. We discussed because of abrasion, wind-borne grains of sand is most prevalent within the first 3 meters of the ground. Why? Because the wind is not able to lift them up more against gravity, causing the bases of outcrops to erode more rapidly than their tops. This is a reason why you see mushroom rocks are being found. Fine. So remember, mushrooms are rocks. Why it is formed? It is formed because winds are eroding. Winds are eroding the lower part more as compared to upper part. Why they are eroding lower part more? Because of the sand particles which wind is carrying. They erode, they abrade the rocks. Fine. Now the second you have is a Jugan and Yardan. So this is what we call as a Jugan. Jugan is basically ridge and furrow landscape. So like this, you'll find highland, lowland, highland, lowland, highland, lowland, highland, lowland. This is called as nothing but what? This is called as a Jugan. Jugan is what? Ridge and furrow. So highland you're gonna find, lowland you're gonna find, highland, lowland, highland, lowland. Why this happens? let's say this is how the this is how the rocks are there. Now let's say wind flowing like this. When wind flows like this, what will happen? Okay, they're gonna erode this softer part of the rocks. So what will happen? You'll see harder rock, softer, harder, softer, harder. So what you'll find, highland, lowland, highland, lowland, highland, lowland. So this is what we called as a Jugan. This is what we called as a Jugan. So Jugan is basically what? Jugan is basically the ridge and furrow. Ridge means greater height, furrow means what? Lower height. Clear? So this type of thing is called as what? This type of thing is referred as a Jugan. So this definition, what it is written, these are ridge and furrow landscape found in the desert. Wind abrasion turns a desert surface which has a layer of resistant rock underlain by a layer of weak rock. So as we discussed, weak rock will be eroded, resistance rock or strong rock will not be eroded. So strong rock will have a strong rock will have a ridge and the weak rock will constitute your furrow. Fine. So the first that is made by wind erosion is what? The first that is made by wind erosion is mushroom rock. The second, that is Jugan. Mushroom rock, single rock, when it is eroded at the base, you'll see mushroom rock. When there is a series of rock made up of harder, softer one, then harder will not be eroded, softer will be eroded, and this ridge and furrow will create what? Will create Jugan. The Yardang, the third one, Yardang, is also a similar concept, but only difference is what? Only difference between Jugan and Yardang are what? These are vertical band of hard and soft rock commonly found in Atacama Desert region. Clear? They are commonly found in Atacama Desert. So vertical band of hard and soft rock. Clear? So as we discussed, rocks are hard and soft. So when you have vertical means like this. So you may find rocks like in this nature. This is a vertical nature. If rocks are arranged like this, it is going to be what? Horizontal nature. Clear? So it is a vertical band of hard and soft rock which are found generally in Atacama Desert in Chile region. Clear? So this is the difference lies between Jugan and Yardang. Which one? No, you have hard and soft rock both. Yeah, when softer part is eroded, it becomes Jugan. Okay. Then you have next one, mesas and buttes. Now this is what? This is basically the buttes part, and this is basically nothing but mesas part. Now, if you are finding something, this part, flat top. This is a flat top, almost flat top that you are finding, and this flat top is when narrow in nature. Then it is going to be called as what? The buttes. When it is wider in nature, flat top is wider in nature, then it is going to be called as what? Mesas. Okay, so mesas and buttes, what is the difference? You're gonna, in both the cases, you're gonna have flat top. Here the flat top will be narrow in nature with steep side, and here what will happen? You'll also have steep side, but here the flat top is going to be much bigger in nature. Clear? So this is what we call as a mesas and buttes. So you'll find this. So what we have written, a mesa is an isolated flat top hills or mountain with steep side. So you're gonna find flat top, steep side, smaller area than a plateau. Clear? So we discussed it is a smaller area than the plateau, but this is a flat top with steep side, though smaller in area than a mesa. Clear? So it is a buttes. This is nothing but mesa. Fine. So what we discussed, mushroom rock, second is what? Jugan, the third is Yarden, the fourth is what? Mesas and Butt. The fifth is your Inselberg. Inselberg is what? This type. So now what you are getting? Isolated rock with a rounded top, not flat top. So when you find isolated rock with a rounded top, it is going to be called as what? Inselberg. It is going to be called as a Inselberg. So it is isolated residual hills rising abruptly from the ground. It will have a rounded top, steep slope with rounded top. That is what characteristic of Inselberg. Clear? So flat top, if it is okay, small flat tops, but is okay, the bigger flat top, it is going to be called as a Mesa, and rounded top, then it is going to be called as a Inselberg. Fine. The last that you see is okay, ventifact or decanter. So this is okay, what? Ventifact or decanter. So you can see what definition it is written. It is a rock that has been abraded, pitted, east, grooved, or polished by the wind. So any rock that is okay, what? That is okay, eroded by the wind, polished by the wind, east or grooved by the wind, then it is called as what? Then it is going to be called as a ventifact or decanter. These geomorphic features are most typically found in arid environment, means desert environment. So these are referred as what? Ventifact or decanter. Since they are modified by the wind, they are also referred as a wind canter, decanter or wind canter. So that is okay, also okay being given. Clear? So any rock that is okay, what? Abraded, that is, as abraded means what? As we discussed, sand particles will hit it, so the rocks will get abraded, polished, pitted by the wind driven sand or ice crystal, then such okay is going to be called as what? Ventifact or decanter. These are going to be found in what? Arid environment. Arid environment. Fine. So that's why you're going to find different types of what? Different type of stones, or you can find this type of stone. That one side is what? Abraded, polished, okay. You can see this is okay, highly smooth surface because of polishing, etc. You can find stones like this, okay. It has been abraded, grooved. So you'll find different type of stones in case of nothing but okay, what? In case of arid environment, and these are referred as what? These are referred as a ventifact or decanter. So what are the 6 types we have discussed? The first is what? Mushroom rock. The second is what? Jugan. Jugan is what? Highland and lowland. Yarden, harder and softer rock. Then mesas and buttes. Mesa means what? Flat but wider top. Buttes means what? Flat but narrow top. Inselberg means what? Rounded top. And lastly what? Ventifact and decanter. Different stones which are okay eroded by the winds. They are going to be called as a what? Ventifact and decanter. The last part that you find with regard to wind is what? Landform of wind deposition. So till now we were discussing about landform made by wind erosion. What? When wind were eroding, how wind were eroding? Through deflation, through attrition, through abrasion. Now what are the landforms that are going to be formed because of wind deposition? So 2 important things, dunes and loess. Fine. So what is okay the dunes and what is loess? Basically this is what we call as a dunes. Dunes is what? A sand hill or sand ridge. So when, as we discuss in a desert, what will happen? Sand desert, you'll see deposition of sand. So in sandy desert, you'll see deposition of sands. So when a sand hill or sand ridge is formed, usually in desert region or near lakes or ocean, it is going to be called as what? It is going to be called as a dunes. Clear? So when wind will form this type of sand hill or sand ridge in a desert region, it is going to be referred as a dune. Dunes can be of two types. They are called as a barkans, or they are referred also as a longitudinal dunes or sif. There are two type of dunes. One is called as a barkan. The second is called as a longitudinal dunes or sif. Fine. So the first is what? First is nothing but okay, barkans. What is barkans? Now this is a barkan. Barkan is a crescent shape. Crescent shape is how crescent shape? Like this shape. So crescent shape is which shape? Like this shape. This is a crescent shape. When deposition of sands happens like this, then it is going to be called as what? It is going to be called as a barkan. So barkan is what? Barkan is a crescent shape dunes. Fine. Why barkans appears like this? Because barkan face the wind appearing convex and are produced by wind action predominantly from one direction. When wind is continuously blowing from one direction, then you're going to find which type of deposition, barkan type of deposition. Clear? So for example, in this figure you are seeing wind direction is what? Wind direction is like this. So whatever the sands that are being brought is deposited like this or deposited like this, then you're gonna say crescent shape type of dunes. Clear? So when wind continuously moves from one direction, predominantly from one direction, then you're gonna find the barkan shape. Clear? Any doubt regarding this one? It is also referred as an arc shape. Barkan is also referred as an arc shape because you are creating an arc or crescent shape. Fine. So what is a dunes? Dunes is formed due to what? Due to wind deposition. So when winds are bringing the sediments and depositing it, it is called as a dunes. Dunes we discussed can be categorized into two types. One is called as what? Barkan, and the second is called as a longitudinal dunes or sif. The barkan is what? Crescent shaped dunes, and this crescent shaped dunes is formed due to what? Due to wind moving only from one direction. When wind moves only from one direction, then you are going to find crescent shaped dunes. Fine. So like in Indian Thar desert, you can find what? You can find this type of dunes. Clear? Crescent shaped dunes. So this is how, you are finding the crescent shaped dunes are something that are there, or like this. In reality, how you are seeing crescent shaped dunes? Like this, you are seeing crescent shaped dunes in the reality part. Fine. The second is what? Sif or longitudinal dunes. Sif or longitudinal dunes. This is called as a second type. So if you remember, we discussed longitudinal waves. What is longitudinal waves? That move in the form of compression, rarefaction, like this. So that's what longitudinal dunes is like this only. They will be what? They will be having a ridge. They will having what? Lesser sand deposition, more sand deposition, lesser sand deposition, more sand deposition. So that's why it is called as a what? It is called as a longitudinal dunes. For example, if you see figure, you'll find dunes like this. So you are finding more sand deposition over here, less sand deposition over here, more sand deposition over here, less sand deposition, more sand deposition, less sand deposition, more sand deposition, less sand deposition. When such type of deposition happens, it is going to be called as what? It is going to be called as a longitudinal dunes or sif. Fine. So sif is a long, narrow sand dunes or chain of dunes. So you see high, low chain of dunes you are finding, generally oriented in a direction parallel to the prevailing winds. So dunes are the first one, barkan, is going to form because wind is moving only in one direction. This type of dunes are going to form when winds are changing its direction. When winds are changing its direction, then you're going to see the longitudinal sif or dunes are going to be formed. Fine. So the first type of deposition is what? The first type of deposition is dunes. Dunes are what? When sands are deposited by the wind in the desert, these are going to be called as what? These are going to be called as a dunes. Dunes can be of two types, Barkan dunes or longitudinal dunes or sieve. Barkan means the wind is blowing from one direction and depositing the sands, so it will form a crescent shape, dunes. And when winds is blowing sometimes from this direction, sometimes from this direction, sometimes from other direction, then wind direction, if keeps on changing, then we are going to get longitudinal dunes or sieve concept. So that's why you'll find highland, lowland, you'll find these type of nothing but things going to be formed, and this series of dunes are referred as longitudinal dunes or sieve. Fine. Now there can be another scenario. Let's say wind are let's say this is this is nothing but earth's surface. Now wind is blowing and wind is carrying the sand particles. Either wind can deposit these sand particles in the desert limit or outside of desert limit. They can carry the sand particles also outside of desert limit also. So if wind is having no blockage, so they will not deposit it over here. They can also move it outside of outside of desert limit. So when wind takes the sand outside of the desert limit and deposit it over there, then it is going to be called as what? Then it is going to be called as what? Loises. So when wind takes the sand particle outside of desert limit and deposit it over there, then it is going to be referred as what? It is going to be referred as a loess. So what is loess? It is said it is predominantly silt-sized sediment that is formed by accumulation of wind-blown dust beyond the desert limit. So when the dust particle is taken by the wind, sand particle is taken by the wind beyond the desert limit, then it is going to be called as a loess. And since it is a sand, you know that sand particles are bigger particles. So sand are going to be what? Extremely porous. It is going to be what? Rich in lime. Fine. So this is all about what? This is all about landform that are being made by the wind. So as we discussed, wind landforms are more dominated where? In the desert region. How many types of desert we have? 5 different type. What are the 5 different type? Hamada, that is rocky desert. Yes. Reg, that is sandy desert. Erg, that is stony desert. Sorry, reg, that is stony desert. Erg, that is sandy desert. Then you have what? Then you have badland, and then you have mountain deserts. Those are the 5 type of deserts. Then we discuss always deserts are located where? They are located in the tropics region. Hot deserts are always located in a tropics region, as it is a zone of high pressure, and they are on the western margin because of cold oceanic current. Fine. Different type of deserts also we have discussed. Just remember the name: sandy deserts, Sonaron desert, Muzave desert, Kalahari desert, Taklamakan desert, Gobi desert. All those deserts you just keep in mind. Then we discussed the wind can what? Wind can forms landform either due to erosion process or due to deposition process. Due to erosion, what is happening? You see mushroom rock, you see ventifactor decanter, you see what? Jugen, you see Yardang, you see also Misas and Bates and Inselberg. These are the landform due to erosion. And what are the landform due to deposition? It is dunes. Dunes can be of two types, Barkan and longitudinal sieve, and second is what? Loess. So these are what? These are the deposition. And we discuss what action dominate in the wind landform. What action dominate? Abrasion, attrition, and deflation. These are dominating in the wind region. Clear? So these are all landform made by wind. Fine. Have a break and then we'll continue.
So can we go to
Page 24.
Indian fairness. Telugu, maybe not the Telugu states. If you get a person, you will come.
Saturday, 10:30 to 11:30. Because I'm express. 10:30.
Should I tell you? Why?
I will. You have to come.
If I get the things, even though if you take long days, go on me on this,
Tomorrow is the one.
yeah.
Why don't you not come? We not the tomorrow. Actually, we will come.
Yeah, I will. Will it come?
Why is it that?
I don't know. She has one.
Now we are coming to another landform which is called as a karst landform. So it is referred as a karst landform. So any region where rocks are made up of what? Where rocks are made up of limestone and chalk are referred as which type of region? Karst region. So any region where rocks are made up of what? Where rocks are made up of limestone and chalk are referred as what? Are referred as a karst region. So you can see a karst region. What is the definition? A region with large stretch of limestone possesses a distinct type of topography, and this type of region is referred as what? Karst region. Fine. So any region where the rocks are made up of what? Rocks are made up of the limestone and chalk. These regions are referred as karst region. And limestone is made up of calcium carbonate, as we discussed, CaCO3. Or if magnesium is present, along magnesium carbonate are present, then it is going to be called as what? Dolomite. It is also referred as a dolomite. So limestone is basically calcium carbonate, but if magnesium present, then it is going to be called as what? Dolomite. And chalk is basically the purest form of limestone. And purest form of limestone is referred as a chalk. Fine. So these are important terms you have to keep in mind. What is karst region? Yes. Purest means, okay, no impurities are there. The chalk is the purest form of what? Limestone. Limestone purest form is referred as a chalk. Yeah. Fine. So what is?
When you are explaining the bond after introduce this manner than
No, I'll just, because this, for this I have to show figure. That's why I'm just okay doing with the PDF. I'll go with the board only. Okay, only for, because here what is ventifact, what is decanter, what is the, how do you see gauges? Okay, for this I have to make a figure. So that's why I made it a PDF.
understanding part better.
Ah.
You are telling the keywords.
Yeah. I'll do that. I'll do that. Okay. Once okay, this landform part is over, I'll go with the board part only. So what you have to keep in mind is what? What you have to keep in mind is what is limestone? Limestone already we have discussed. It is a kind of which type of rocks? Sedimentary rocks. And what you find is limestone is what? Limestone is made up of calcium carbonate, but when magnesium is present, then it is going to be called as what? It is going to be called as a dolomite. And a region where large number of calcium carbonate are present or limestone are present, this region we call it as what? This region we called it as a karst region. Clear? So since limestone is okay, what? Limestone is a softer one. It erode easily, and as a result, it forms different type of landforms. So that's what we call as a karst landform. So when you erode the limestone, when you erode the chalk, when you erode the dolomite, what type of landforms are going to be formed? That are called as what? That are called as a karst landform. Fine. Now, this is characteristic feature of karst region. What character that you find in a karst region? Now, the first thing it is written, there is a general absence of surface drainage. Clear? There's a general absence of surface drainage. You don't find water moving onto the surface. You don't find water moving onto the surface. Whether water will go underground and move. Clear? So water will go underground and move, and that's why what we are writing is absence of surface drainage. So absence of surface drainage. Fine. Fine. So second thing that you see is, okay, limestone are which type of rock? They are well jointed rock. Jointed rock means they are not like this. The rock is not like this. Rock is going to be like this, made up of many joints. Rock is going to be like this, made up of many joints. So that's why these are called as what? These are called as a well-jointed rock. These are not like one series of rock. They will be made up of many jointed rocks. That is okay there, clear? And these joints, through these joints only, you see water will go underground. Through these joints only, water will go underground. So that's what it is written, joints and crack that rainwater find its way to the underlying rock. So when these rocks are there, joints are there, through these joints only, water will move underground. Fine. So this is how you are finding. If you see this particular figure, you don't see water moving on what? You don't see water moving onto the surface. On surface is not there, but you see water moving over here, no? You see water is moving like this. So this is okay, what? This is a underground. Water moving underground, not onto the surface. Clear? And these are well-jointed rock. These are well-jointed rock. You can see it is made up of many jointed rock. And over a period of time, this joint will get enlarged. This joint will get nothing but, okay, enlarged. When water will erode it, this joint will get enlarged. You know that calcium carbonate reacts with what? Water to form calcium hydroxide. So it is going to erode the rocks. It is to erode the rocks. And as a result, you will see what? You will see nothing but, okay, this crack becomes widened. This crack becomes widened. Clear? So the widened part is called as a grike. The widened part is called as a grike. The height part is called as a client. So there are two terms, client and grike. So this widened part, the through which water is moving down, this is referred as a grike. And the upper part is referred as what? Upper part is referred as a client. Clear? So the first characteristic of the karst region, that you don't see water moving onto the surface. That is okay, one thing. Second characteristic we have written, rocks are what? Jointed rocks. They are made up of jointed rock. Over a period of time, this joint will get, or crack will get enlarged. This enlarged part is called as a grike. The high part is called as a client. Fine. So this is what you are finding, that limestone are what? Limestone are well-jointed rock, and it is through the joint and crack that rainwater finds its way in the underlying rock. So this is a second characteristic of the karst region. Third thing, progressive widening by solution. So as we discussed, the calcium carbonate react with what? Water. So as a result, crack will get widened, and these, okay, what? These features are called as a grikes and clients. Enlarged joints are called as a grikes, and isolated rectangular block is called as a client. Fine. So these are the characteristic feature of the karst land. So the first is what you have to keep in mind in the karst region. What is karst region? Where rocks are rich in what? Rocks are rich in limestone. Where rocks are rich in limestone or dolomite. Another term that we have used is, if magnesium is present, it is going to be called as a dolomite. Second thing what you have to keep in mind, that water will not flow onto the surface, rather it will move underground. Third thing, that it is consisting of well-jointed rocks. It is not a, it is okay having cracks. These joints are there. This is okay, well-jointed rock. Over a period of time, these cracks will get enlarged. This enlarged part is called as what? Grikes. And okay, the isolated blocks is called as a client. Clear? Now, next thing that you find, this is how you see karst region. This is how you see karst region. So you find rectangular block with, okay, what? This is called as what? This is called as a client, and this widened part is called as a grikes. So this is how you find the karst topography or karst region in reality. Fine. Now there is another concept which is referred as what? Which is referred as a sinkhole. Now in this concept, you're going to find something called sinkhole. Now what is a sinkhole? So you can see that is written as a doline or sinkhole. Doline or sinkhole. So this part, you can see it is called as a doline or sinkhole. It is written over here. Clear? So what happens is what happens is when water falls, what will happen? We discussed, because of the grikes, water goes underground. When water goes underground, this cracks becomes more widened. When it becomes widened, it becomes okay what? It becomes a sinkhole. When it widens, it becomes what? Sinkhole. And it is also referred as a doline. When it further get widened, it is also referred as nothing but okay, doline. So doline or sinkhole is going to be formed. Clear? Any doubt regarding this one? So just now we discussed, you have a client, this rectangular block, and this is part is nothing but okay, referred as a gripe. When gripe get enlarged, water will starts to move underground, and this is called as what? This is called as a sinkhole. This is referred as a sinkhole. So what is the definition for sinkhole? So you can see on the surface of limestone, there are numerous shallow holes, which are okay, small depression carved out of the solution. Rainwater sink into limestone. A number of shallow holes becomes larger, and it is referred as a doline. It is referred as a doline. So as we discussed, grikes. So you find grikes. Grikes is okay what? Grikes get enlarged. It becomes okay what? Sinkhole. When number of sinkhole like this okay combines to form a bigger sinkhole, it is called as what? Doline. When number of sinkhole combines to form a bigger, it is called as what? It is called as a doline. These are found not inside earth, these are found in these caves, the limestone rocks. If limestone rock is there, in the limestone rock, if you are creating a cave, that's when okay, you're going to get what? Stalactite and stalagmite. They're not found interior of earth. Let's say this is okay, the surface of earth. This is the surface of earth. Here you'll finding what? Limestone rock. Now what will happen is okay, here okay, at this part, now water as we discussed is moving underground. When water moves underground, here you will see what? Stalactite. Here you will see what? Stalagmite. This is a cave, entrance of the cave. Clear? So cave is created in what? Cave is created in a rocks. Okay, and because of okay, the water moving underground, you will see nothing but okay, creation of stalactite and stalagmite. Clear? Any? So if question comes, stalactite and stalagmite are a feature of which particular region? It is going to be feature of karst region, because limestone, it is made up of what? It is made up of limestone. It is going to be feature of which region? Karst region. Clear? What is a karst region? We discussed where rocks are rich in what? Limestone or magnesium, dolomite. Clear? So that's why you will find these features. We discussed underground feature that you find in karst region are called as what? Underground feature that you find in karst region are stalactite, stalagmite, as well as pillars. Stalactite, stalagmite, as well as pillars. These are the underground feature that you find in a karst region. Fine. So this is okay, basically what? This is basically the features that you are seeing. So as we discussed, if it is hanging from the roof, it is going to be called as what? Stalactite. And if it is growing from the bottom, then it is called as what? Stalagmite. And once both join together, then what will happen? Pillars are going to be formed. Like okay, you see here it is okay, from the bottom top it is joining, it is going to be called as a pillars. So what happens is, this is okay what? This is a rock, this is a cave which is being created. Because water moves underground, this water reacts with calcium carbonate. As we discussed, it forms what? Calcium hydroxide. It forms calcium hydroxide. When this water evaporates, okay, this calcium hydroxide okay hangs like this. Okay, here also it hangs like this. If it falls on the bottom because of influence of gravity, it starts to grow from nothing but okay, bottom. These features are referred as a stalactite and stalagmite. Fine. So what is a stalactite? As we discussed, they are sharp, slender, downward growing pinnacles that hangs from the cave roof. If it is hanging from the cave, then it is going to be called as what? Stalactite. It is hanging from the cave roof, then it is going to be called as what? Stalactite. And these are sharp, slender. Slender means what? Very thin, that is called as a slender. Sharp, slender, downward growing pinnacle that hangs from the cave roof is called as a stalactite.
Some now about the water will be occurring and the structure will be formed hanging
From the roof.
But how does that occur beneath on the surface?
On the surface, when let's say, okay, what happens is what? Let's say this is okay, the limestone rock. This is a cave part. Now water is coming down like this, and okay, what will happen? It starts to grow like this. When it becomes more heavier, then what will happen? Gravity will attract it. It will start from nothing but okay, fall down. Then it starts to grow also from the bottom, also from nothing but okay, top. And as a result, what will happen? Pillars are going to be formed. Fine.
So, sir, stalagmite is basically accommodation of stalactite.
Yeah, when a stalactite falls down, it becomes a stalagmite because it grows from the bottom. When it hangs from the roof, it is called as a stalactite. When the same thing grows from the bottom, it is called as a stalagmite. Fine. So what is a stalagmite? Now here water carries calcium carbonate in solution. When this line charge water evaporate and leaves behind solidified calcium carbonate, it trickles down and drop to the floor. So when it drop to the floor, it is referred as what? Stalagmite. It is referred as a stalagmite. And when both joins together, stalactite and stalagmite, it is called as a pillars. Fine. So this is all about karst topography. So if question comes, what is a karst region? Karst region is basically where the rocks are rich in what? Limestone, chalk or dolomite. When magnesium is present, it is going to be called as a dolomite. What is a characteristic feature of karst region? There is no surface water. Water will move underground. Second, rocks is going to be what? Jointed. This joint is going to enlarge over a period of time. So what will happen? The upper part, isolated part, is going to be called as a client. The lower part is going to be called as a grikes. When grikes further enlarge, it becomes a sinkhole. When mini sinkhole combines, it is going to be called as a doline. When mini sinkhole combines, it is going to be called as a doline. Since water is moving underground, in the case, if it is hanging, this is hanging from the roof, then it is going to be called as a stalactite. If it is going from the bottom, it is going to be called as a stalagmite. And if both combines, it is going to be called as a pillars. Clear? Any doubt regarding this particular part? So this is all about what? This is all about karst topography. So this finishes your what? This finishes your exogenic part. So we discuss exogenic is what? Exogenic is weathering and erosion. Weathering, we discussed physical weathering, chemical weathering and biological weathering. Erosion, we discussed agent of erosions are there. What are agent of erosion? Wind are there, glaciers are there, waters are there. In karst region, you see erosion. So these are different landforms that are formed due to erosion. Fine.
So, how much geomorphology is still
We'll two more class, 2 or 2.5 class to finish your morphology. After this, your theories are there and lakes and plateaus that we have to cover.
So, how do
Mhm.
geomorphology
To understand the concept, if you understand the concept, like how do you remember a film story? You have watched the movies 10 years back, you remember the story. Why you remember the story? You remember the song. Why? You have heard it somewhere, okay, some 10 years back, you remember the lyrics. Okay, why you remember? Because it is like a story. Okay, so when you form a story narrative, how things are happening, it becomes easier to remember. Fine. So why earthquake is occurring? So you have to remember endogenic process. What is endogenic process? Sudden forces, slow forces. So make a narrative how things are happening. It has become easier to remember. And minor terms like, okay, we discuss decanter or ventifact. Okay, what is sinkhole? What is line? Okay, this will come. Okay, once you revise it one or two times. If you revise it, it will get fit in mind. Fine. So this finishes your concept of the exogenic forces. Now we are coming to the tectonics part. So there are 5 theories that you have to keep in mind, which is mentioned in your syllabus. The first theory is continental drift theory. Continental drift theory. The second theory is convectional current theory. Convectional current theory. The third theory is your paleomagnetism. The fourth is your sea floor spreading theory. Sea floor spreading theory. And the last theory, that is present theory, is your plate tectonics theory. Plate tectonics theory. So these are 5 theories, that is what you need to read from geomorphology perspective. One is called as a continental drift theory. Second is convectional current theory. The third is paleomagnetism theory. The fourth is sea floor spreading theory. And fifth is called as a plate tectonics theory. Clear? So what is term tectonics means? We are using the term tectonic because all these particular theories are trying to explain the tectonic part itself. What is the thing that is happening, which is creating continent, oceans, volcanic eruptions, earthquake. All these theories is trying to explain that particular aspect only. Clear? So the term tectonics means it is a study of what? It is a study of forces and processes. Forces and processes that are taking place what? Below the surface of Earth. It is a study of forces and processes that are taking place below the surface of Earth. This is going to be called as what? This is going to be called as a tectonics. Clear? What is forces? What is forces? So remember, we discussed why volcanic eruption is happening. Which forces is responsible for convectional current? So forces are your convectional current, which are generated in mantle region. So you are trying to study about that. Convectional current generated in mantle. Convectional current generated in mantle. What are the processes? Processes are your folding, faulting, and other such processes. Okay, when you are studying that, it is called as a tectonics. Okay, so the term tectonics means what? Tectonics means it is the study of forces as well as processes. Forces are what? Convectional current that are generated in the mantle region, and processes are what? Your folding, faulting, clear, earthquake generation, volcanic eruption. All these are processes that are taking place inside the Earth. So when you are trying to study that, it is going to be called as a tectonics. Clear? And how this tectonics, this study comes because of evolution of these theories. Okay, so ultimately we are reaching to which theory? Plate tectonics theory. But plate tectonics theory has evolved because of these theories. So the first of these theory is called as what? Continental drift theory. So we'll take up the first theory, which is called as a continental drift theory. Continental drift theory. So this theory, continental drift theory, has been proposed by Alfred Wegener. The one that has proposed this theory is Alfred Wegener. He has proposed this theory in 1922, in 1920s, early 1920s. Clear? So for geologists, okay, this was what? This was nothing but always a question that how the continent has been created. How the continent has been created. How we have a 7 continent right now. So currently we have what? 7 continent: Asia, Europe, Africa, Australia, North America, South America, and Antarctica. What has led to creation of these 7 continents? This was always a puzzling question for whom? The geologist. And Alfred Wegener tried to explain that how continent could have been formed. Clear? Now this theory have been discarded, but you know that how the science has developed. We discuss something will be proposed, then what will happen? Criticism. Yeah, you try to find evidences for that, then criticism will come, the new theory will be built. So that is why this is called as a building block, stepping stone of all other theories, which is conventional current theories or plate tectonics theories. All that starts from where? From the continental drift theory. Clear? So what Wegener says in the continental drift theory, what he proposed was that initially the Earth was having a single landmass. That initially the Earth was not consisting of 7 continents. It was consisting of only one continent, and this is called as a supercontinent. He called it as what? He call it as a supercontinent, and the supercontinent was referred as a Pangaea. So he referred this supercontinent as a Pangaea. He says that initially there was no 7 continents, there was only one continent, and the supercontinent was referred as a Pangaea. And you know that continent is surrounded by water, that is oceans. This continent is surrounded by water or the ocean. So he called this big ocean, that is okay, there is Peninsula. So he called this big ocean as what? Peninsula. Clear? So what he says, what initially there was not 7 continents, there was only one big continent, supercontinent, which is called as what? Which is called as a Pangaea, and this Pangaea is surrounded by what? Surrounded by water, and this water is called as a Peninsula. Fine. Now what he's saying that after a period of time, what had happened? This Pangaea got broken down into 2 parts. This Pangaea got broken down into 2 parts, and these parts are referred as Gondwana land and Angara land or Laurasia. Another term that has been used is Laurasia. So he says that these 2 parts, later on this supercontinent got broken down into what? Got broken down into 2 parts, that is Angara land or Laurasia, or the second part is called as the lower part is called as the Gondwana land. Fine. Now as we discussed, what is there now surrounding this is what? Your oceans. Surrounding this is what? Your ocean. Which ocean? We call it as a Peninsula. But when these 2 parts are broken down, a small water is also developed over here. Now he called this water, which is developed between what? Which is developed between these 2 continents, as a sea, which is referred as a Tethys Sea. So he called this water as what? He called this water as, okay, the small sea that develops, okay, between these 2 as a sea called as a Tethys Sea. Clear? Later on, he says that this Angara land further broken down and Gondwana land further broken down, leading to formation of what? Leading to formation of 7 continents. Leading to the formation of current 7 continents. Clear? This is what the theory that has been proposed by Alfred Wegener in 1922. Clear? Now at this time, in 1920s and early 1900s, we didn't have much information regarding what? We didn't have much information regarding oceans. Okay, what is like ridges? We discussed ridges are present in the ocean. Sea mounts are present. We discussed trenches are present. We didn't have much geographical information regarding those particular things. Clear? Later on, when technology evolved, you see submarine games. Remember, the Navy have what? Indian Navy have a submarine. So, okay, submarine goes underground and what? They try to attack the enemy underground. So when you develop, okay, further technology, you started going underground, then you started finding all these features inside the oceans. That generally has happened in early 1940s. Clear? So 1935, 1940s, you'll see a lot of discovery inside the oceans has happened. Clear? So that's why Wegener theory is not trying to explain anything regarding ocean, because at that time not much information were there regarding the ocean. Only what was information present? Continent information was present, and how this continent has formed, that was a puzzling questions. That's why Wegener tried to explain this particular continental drift theory. Fine. So what is happening? Continental drift theory, he says that, okay, what? Initially there was a supercontinent. This supercontinent is referred as a Pangaea, surrounded by ocean called as a Peninsula. Over a period of time, Pangaea got broken down into 2 parts, which is referred as what? Angara land and Gondwana land. Angara land and Gondwana land, a sea develops which is called as a Tethys Sea. Further broken down of Angara and Gondwana land led to formation of what we call as a 7 continent. Clear? Now, when he is proposing this particular theory, he's saying, he is giving certain evidences also, and he is talking about certain forces also. So he's giving certain evidences also, and he's talking about certain forces also when he's trying to explain. Now, why people will believe that initially what? there was a supercontinent. Okay, you have to give evidence, no, that how supercontinent was there, or if supercontinent was there, why do you see formation of 7 continent? There must be some force that is responsible for breaking this continent, and as a result, now what is happening? 7 continents are being formed. So you have to give evidences with regard to nothing but, okay, what regarding nothing but, okay, this assumption what you are making, and secondly, you have to talk about the forces which is responsible for breaking of Pangea into 2 part, and further breaking of nothing but, okay, 2 part into 7 continents. So that's why he's talking about that these two things are happening due to 2 forces. And one thing he says that a pole wandering force, or also called as a pole fleeing forces, and the second he called it as a tidal force. Secondly, he is calling it as a tidal force. So he's saying that all these breaking of the continent is happening due to 2 reasons. One is called as a pole fleeing force, and another is called as nothing but, okay, tidal force. Fine. Now, what is pole fleeing force? What is a pole fleeing force? Now, this force is generated because of rotation of Earth. Because Earth is rotating, so rotation of Earth causes which to generate? Centrifugal force to generate. And this centrifugal force is responsible for what? The centrifugal force is responsible for pole fleeing forces. Clear? So he's saying that rotation of Earth is rotating, Earth is not static. When Earth is rotating, what will happen? You know that any body which moves in a circular motion, 2 type of forces are centripetal force and centrifugal force. So he's saying that centrifugal force are generated, and because of this centrifugal force, what will happen? Which force are generated? Pole fleeing forces are generated. Clear? Any doubt regarding this particular thing? Now, this pole fleeing forces is responsible for northward movement. Northward movement of continent. This pole fleeing forces are responsible for northward movement of continent. And the second forces is the tidal forces. The tidal forces is responsible, he's saying that it is responsible for westward movement of continent. It is responsible for which type? It is responsible for westward movement of continent. Clear? So pole fleeing forces and tidal forces it is talking about. So pole fleeing forces is generated due to what? Earth's rotating, which is generating centrifugal force, and it is responsible for what? It is responsible for northward movement of the continent. So let's say this is a continent. Now what will happen? One part is trying to move north. So when one part will try to move north, what will happen? Breakage will happen. This is the reason why Pangea is got broken into Angara land and Gondwana land. So he's talking about, okay, these forces. Clear? Secondly, tidal forces. You know that tides are generated due to what? Due to gravitational attraction of moon and sun. Tides are generated due to what? Gravitational attraction of moon and sun. Clear? So as we discussed, this is sun, the earth is rotating around who? The earth is rotating around sun, and we discussed moon is rotating around what? Earth. So as a result, moon is trying to attract earth, the sun is also trying to attract. Clear? Both have a gravitational pull, and this gravitational pull is generating what? Generating which type of forces? Tidal forces, and this tidal forces is responsible for which type of movement? Westward movement of the continent. Clear? Any doubt regarding this one? So this is what the concept, okay, he is talking about. Clear? Now suppose again the same thing, if we take this bottle and I start rotating this particular, okay, bottle, what will happen? You'll see water will move where? To the upside, no? If you rotate it, what will happen? Water will, okay, what water level will start moving up. Why it will start moving up? If I rotate it, let's say this is like this. If I start rotating, what will happen? You'll see water may come out, no? Okay, why water may come out? Because of centrifugal forces. Centrifugal forces are which type of forces? Outward forces. Okay, they are acting outward. So since I'm rotating, the water may move outward, and this outward, so water is moving where? Up or down? It is moving up. So that's why when earth is rotating, continents will also move where? To the upward direction, and that's why this is, okay, responsible for which movement of the continent? Northward movement of the continent. Fine. And because of the tidal forces, since, okay, they are being attracted by the sun and moon, Okay, these are responsible for which type of movement? Westward movement of the continent. So these are the two forces he has given, that why you see Pangaea got broken down into two parts, Angara and Gondwana, and later on further breaking of the continent is something that is okay happening. Clear? Why? Because of tide there is a westward movement. This is what proposed by Wegener. Now this is not true. We are coming to the criticism, okay, and because of criticism what will happen, you see new theories are going to come. Clear? So just what Wegener is proposing, I'm just telling you that. Okay, so Wegener says why the breaking of continent is something that is okay happening. Breaking of continent is happening due to these two forces. Pole freeing forces, why it is generating? Because of the rotation of Earth. Centrifugal forces, which is responsible for what? West, okay, northward movement of the continent. And the second is the tidal forces. This tidal forces is acting because of what? Because of attraction of moon, attraction of nothing but okay sun, and as a result this is responsible for westward movement of the continent. Clear? Any doubt regarding this one? Now why he is also giving evidences. One evidence is, like, give me this map. So one evidence is, now if you look at okay world map, if you look at the world map, this is okay the world map that you are finding. Where is the equator line? This is the equator line. This is a middle part. Equator is the middle part. Clear? Equator means 0 degree. Clear? Here 90 degree above, 90 degree nothing but okay below. So this is the equator line. Now where you see more continent? Above the equator you see this is a continent, this is continent, this is continent. Above the equator you are seeing more number of landmass. Okay, now below the equator you find only this much landmass, this much landmass, and this much landmass. Okay, so below the equator you are finding what? Less landmass. Above the equator you are finding what? More landmass. So that's why okay the Wegener saying that why it is happening, why more landmass in the northern hemisphere? It is happening because of nothing but okay what? Pole freeing forces. Okay, so he's saying it is a pole freeing forces that is responsible for more landmass in what? Northern hemisphere, less landmass in what? Southern hemisphere, because continent are moving where? In the northward direction. They are moving in the northward direction. So this is okay what he is talking about. Clear? The secondly, he is okay what? One evidence is that he is giving is what? Physical affinity. So one evidence is he is giving is physical affinity. What is physical affinity? So this part okay if you see is what? This part okay you'll see North America. This part okay you're gonna find what? Southern America. And this part okay you're gonna find what? Africa. Now he's saying that this part of Africa is what? Fitting in over here. Okay, so it's like a jigsaw puzzle. Jigsaw puzzle. Clear? So in jigsaw puzzle you combine many things to form a figure. So that's what he is saying, that okay that it is like this. It was like this. Okay, it was like this. Okay, so this part of Africa is what? This part of Africa was earlier joined to whom? Earlier joined to nothing but okay North America and South America. So this part of okay what? This part of nothing but okay Africa is exactly fitting into what? Exactly fitting into nothing but okay this part of North and Southern America. Clear? Any doubt regarding this one? So this is okay what? Called as a physical affinity. So he says that this part of Africa which is okay broken away from where? Broken away from Northern and Southern America. Why it is broken away? Because this part is exactly fitting into what? Exactly fitting into the space that is okay over here between Northern America and Southern America. So this is what he is giving as one of the evidences, physical affinity. Clear? Physical affinity is being given as one of the evidences. Clear? So like a jigsaw puzzle, this particular part is fitting into this region. So you see this type of nothing but okay continent were there, all were combined together at one point of time. This is okay what explaining supercontinent. That is one evidences okay which who is giving? Wegener is giving. That is one evidences Wegener is something that is okay giving. Clear? But what you see is okay what you see is this is okay the reason why is explaining that the continent are moving what? Continent are moving in the westward direction, because these two parts were joined together with which part? These two parts were joined with the Africa. Now why they have moved away from Africa? Because of westward movement. Okay, so why they have moved away from Africa? Because of nothing but, okay, westward movement, they have moved away from Africa. So that's why he is explaining tidal forces as which type of forces? Westward forces. Okay, so westward forces is explaining that this westward movement is happening due to what? Tidal forces, and this northward movement is, okay, happening because of what? Because of pole freeing forces. Okay, so these are, okay, what? These are nothing but, okay, the two forces which, okay, the Wegener is talking about. And how is, okay, giving evidences? One evidences is giving is what? That more landmass is present where? In the northern hemisphere. Why more landmass is present in the northern hemisphere? Because of northward movement of the continent. And why you see the North America, South America moving west side. Why they are moving west side? It is because of nothing but, okay, tidal forces. So that is what, okay, the Wegener is talking about. Clear? Now other evidences also he is giving. So one evidence is we have talked about, he is talking about physical affinity. The other evidences that he is giving is what? That there is a, okay, presence of similar tillite deposits. There is a presence of similar tillite deposit across continent. This is, okay, second evidences which is giving. There is a presence of similar tillite deposit across continent. This is, okay, second evidences he is talking about. Clear? What is tillite means? Remember, we talked about till. What was till? Rock. Which type of rock? Yeah, after the glacier melt, we discussed, okay, the boulders and others which are left are called as what? Are called as a till. Clear? So tillite deposit, why it is formed? It is formed due to the glacier. It is formed due to what? It is formed due to the glacier, and similar tillite deposit is found across continent. Clear? Similar tillite deposit is found across continent. Clear? Any doubt regarding this one? So if Earth was not united, then how you can find similar tillite deposit everywhere? Glacier will move, no? We discussed when glacier will move, then you will get, okay, which type of deposit? Till, glacial till. So if glacier is moving, then the glacier will what? Leave down these boulders. Then the glacier will leave down these particular boulders and etc., which is called as what? Glacial till. Clear? So this region was uniform. Then only what will happen? This glacial till was created. Now this region has broken down into what? 4 parts. So, okay, this part also contains certain till, this part also contains certain till, this part also contains certain till, this part also contains certain till. Clear? So this till, okay, is present also here, this part is present also here, this part is present also here, this part is present also here. Clear? So glacial till, why it is being formed? Glacial till, why it is being formed? If the glacier would have, okay, what? Glacier would have moved over this region. If how the glacier move on different continent? They can't move on different continent unless and until continent are same. Then only what will happen? Glacier can move. Okay, that is okay there. Clear? So now they have broken down, but okay, what you see is, okay, what earlier they were united. When they were united, glacier has moved and glacier has deposited these till. Now what had happened? They have broken down. That's why the still is present everywhere. So that is what one of the evidences he is proposing, that there is a presence of tillite deposit in Asia also, in Africa also, in South America also. Similar tills are being found, similar glacial tills are being found, which is indicating that there was what? There was a supercontinent. Fine. The third thing is talking about presence of what? Presence of similar types of fossils. Similar types of fossils. Like you will see lemurs, fossils of lemurs or glosto. Okay, similar types of fossils it is talking about. Lemurs, fossils, lemurs are also found where? It is found in Australia, it is found in what? America, that is Southern America, Africa. Similarly, you see this type of vegetations are also found everywhere. So what will happen is, okay, what? The similar type of fossils can only be found when? Similar types of fossils can only be found when okay, they were united. When they were united, then only what will happen? Same organism will live in that area. When they will die off, what will happen? Their fossils will be there. Now what will happen? Continent has broken down. So that's why you see here also, here also, here also, you'll find nothing but okay, similar fossils. Clear? For example, let's say polar bear. Polar bear are living where? In the Arctic region. In the Arctic region, you find polar bear. Polar bear are not found in India. Why they are not found in India? Because okay, they survives in colder condition. They requires what? They requires nothing but okay, the ice sheet. Okay, in India not available, so you don't find nothing but okay, what? Polar bear in case of India. So fossils of polar bear is going to be found where? If fossils of let's say after 100 years, if we are trying to find out the fossils of polar bear, where it is going to be found? It is found in Arctic region. It will not be found in India. Clear? But if similar type of fossils is being found everywhere, what does it indicate? That this organism was present in all these continents, and how the organism can survive in different climatic condition. It is not possible. It will be possible only when what? All the continents were united and have similar type of climate. Okay, that is okay there. So that's what okay is presenting as evidence that there is a similar type of what? Similar type of nothing but okay, the fossils okay that are also present across the continent, that indicate that there was what? There was a supercontinent, and all continent has come out from nothing but okay, the supercontinent only. Clear? Next okay, what you see is okay, is also presenting that there is a presence of similar placer deposits. Similar placer deposit across continent. So another evidences he is giving is presence of similar placer deposit across continent. Clear? Now similar placer deposit means it is a kind of sediment like deposit of golds, deposit of okay what, deposit of other element that you find, because rivers will erode, no? Rivers will erode, wind will erode, and they will start depositing the material over here. So that will create which type of deposit? Placer deposit. Okay, so similar type of placer deposits are being found. For example, when we'll come to distribution of golds, like in world geography, as we discussed, you have this topic, no? Location of industries, where industries are being located, where resources are being located. So you'll find that this particular region of Africa is having what? Having the gold deposits. Clear? And you'll also find what? You'll also find that this region of what? This region of South America is also having gold deposit. How it is possible? How it is possible? They were once what? They were once joined together. So okay, place has been placed like this, and as a result, okay, what will happen? Some has now gone to Africa, and some has now gone to what? Some, because of the breaking, what will happen? The upper part has gone to Africa. The lower part has been where? In the Southern America. That is okay there. So he is explaining that similar type of placer deposit are also present, and this is possible only when continents were nothing but okay, united. Clear? So they were united, similar type of deposits has been there. Now they have been broken down. So here you will find also deposit, here also you will find similar deposit, that is okay there. Clear? So this is another indication he is giving. Clear? Another thing, last okay, evidences that is providing is presence of rocks of seamage. Presence of rocks of seamage. This is okay, another important okay, what? Another important evidences he is providing, that rocks of same age are present also in Northern America. Like if you remember, we talked about which mountains are over here? Appalachian mountains. Okay, we discussed Appalachian mountain. Now similar okay, same age of mountain you will also find in Europe. Okay, so how it is possible? Okay, rocks of same age can be found. It can be found only when continent were nothing but okay, united. Okay, so all these reasons Wegener is presenting to prove his theory. Clear? So what was the theory? Theory was that initially there was a Pangea. Then Pangea is surrounded by Panthesla. Then Pangea got broken down into two parts, which is okay what? Angara land and Laurasia or Gondwana land, separated by which sea? Tethys Sea. Then okay, further breaking down lead to formation of which continent? 7 continent. Clear? What is the force responsible for breaking? Pole fleeing force and tidal force. Pole fleeing forces is responsible for responsible for northward movement, while okay the tidal forces is responsible for westward movement. Why pole fleeing forces are generated? Due to rotation of Earth, centrifugal force. And why you see tidal forces are generated? Due to okay what? Due to gravitational effect and other effect. You will see nothing but okay that is okay causing the tides, gravitational effect of moon and sun. Fine. What evidences is okay providing to support his theory? That okay, yes, okay, that there is okay what? There is the Africa, which is exactly fitting into what? North America and South America. So that is okay. One evidence is more landmass in what? More landmass in the northern hemisphere, less landmass in southern hemisphere, indicating that continents are moving what? Northward. The third evidence is presence of what? Rocks of similar age across the continent. The fourth is what? Presence of similar type of tillite deposit, glacial till deposit, that is okay there. The fifth is what? Presence of similar type of fossils okay across different continent. And lastly, presence of similar placer deposits. Clear? So these are evidences he is giving to support his theory. Fine. Now the modern theory, as we discussed, convectional current, the seafloor spreading, and plate tectonics theory. Plate tectonics theory has now accepted this concept. They have accepted this concept that yes, okay, the continent has evolved a single continent. So assumption what okay Wegener is making is now being accepted. Yes, there was a supercontinent called Pangaea, and from this only you see all other continents are now being created. But other part is being rejected. Other part of Wegener's theory has been rejected by nothing but okay modern theories. Clear? So modern theories have accepted this assumption that yes, okay, the current continent has evolved from what? Single continent. That assumption is correct. But okay, what forces, what evidence Wegener is providing, this has been now rejected by whom? By the modern theorist. Clear? Any doubt regarding this one? Now, why it has been rejected? What is the criticism? What is the criticism? The first thing, the first evidences we discuss what he's giving is what? Physical affinity. That okay, this part is what? Okay, we discussed okay, this part of okay Africa is fitting over in the northern and southern America. Now, it has been rejected because of what? Because you know that landforms are subjected to what? Landforms are subjected to what? Continuous erosion. Continuous erosion. Clear? We discussed landforms are subjected to what? Continuous erosion. Clear? Also, you'll see what? You'll see submergence. You'll also see what? Emergence. We discussed okay, these forces are also acting. So submergence is also happening, emergence are also happening. That is okay there. Let's say this coastal line has okay what? Coastal line has been eroded now because oceanic waves are there. Oceanic waves are coming and they are eroding this particular okay what? This particular region. So let's say this was like this because of oceanic erosion. What had happened? It might be now like this. So you can't say that okay, this is exactly fitting now. So okay, what will happen? This was okay part of what? This was part of supercontinent. You can't say because these coastlines are not okay what? Not exactly what was 100 years ago. Coastline are supposed to what? Coastline are supposed to change because of submergence and emergence, and coastline are going to suppose because of change because of what? Because of erosion. Clear? So they are going to change because of erosion, they are going to change because of submergence and emergence. So you can't say that currently yes it is fitting like this, but you can't say okay that this was how exactly when the earth was formed, because different forces has acted over a period of time, different type of erosion has happened over a period of time. Oceanic waves are constantly eroding the coastal line, submergence is constantly changing the coastal line. So current coastal line fitting with this cannot be said as an evidence for what? Cannot be said as an evidence for the supercontinent. Clear? So that is one criticism that you are finding. Clear? The second major criticism, you know that okay, we discussed continent. The Wegener is not talking about anything about what? Oceans. We discussed Wegener is only in continental drift theory. Wegener is only talking about what? Continent. Is not explaining anything about what? oceans. Okay, so Wegener is not explaining anything about oceans. Is only talking about nothing but okay continent. That is the second major criticism. Clear? Now, if you remember, we discussed there are two type of crust: continental crust and oceanic crust. Remember, we talked about two type of crust: continental crust and oceanic crust. Continental crust is made up of which type of rock? Say yes, okay. And oceanic crust is made up of which type? Mafic. And we discussed which crust is more denser. Oceanic crust is what? More denser because it is made up of iron and magnesium, while this is made up of silica and aluminum. So it is what? Less denser. So continental crust is what? Less denser. Oceanic crust is what? More denser. Clear? Any doubt regarding this one? Now, so this suppose this is okay oceanic crust and this is nothing but okay continental crust. Now Wagner is saying that continent are drifting. Continent are drifting means what? Continent are drifting means what? They are moving from one location to another location. Clear? That is what drifting means. So because of braking, first braking had happened, then what will happen? Westward movement, northward movement. Okay, so they are drifting, they are moving. Clear? How when continent has to move, they have to move okay over which crust? Oceanic crust. Okay, continental crust has to move over which crust? They have to move over oceanic crust. So first they have to break the oceanic crust and then only they can move from one location to another location. Clear? They have to break this particular part, then only they can move from this location to nothing but okay this location. Clear? Now suppose these two are there. These two are there. Now this is okay one rock, this is another rock. Assume this. If I try to hit this rock with this rock, what will happen? If I try to hit with this rock, what will happen?
Erosion or pressure will be defeated, friction, erosion.
Friction, erosion will happen. Which is going to be okay? What destroyed first? This is going to be destroyed or this is going to be destroyed because of erosion? Lighter one is going to be destroyed. Okay, so what will happen? Like if I try to push it away with the lighter one, it will not be able to break it. Rather, this one will be able to nothing but okay break this one what easily. So continental crust is which type of crust? Continental crust is which type of crust? Lighter crust, less denser crust. Okay, so they can't break the oceanic crust and move away. No, for moving away they have to break what? They have to break the oceanic crust, and oceanic crust is more denser. Oceanic crust can't be broken down by the continental crust. Okay, that is okay there. Clear? So that's why the Wegener theory was rejected. That continent are not moving. Continent can't move. Why it can't move? Why it can't move? Because oceanic crust are more denser, and continental crust has to break the oceanic crust. Then only what will happen? They can move from one location to another location, which is not possible because this is more denser. So that is another reason why drifting theory has been rejected. Okay, this is why the drifting theory has been rejected. Clear? Any doubt regarding this one? Yes.
So continental crust is less dense than oceanic crust. But when we talk about the African Valley, the plate is very light. So crust and plate is different.
Yes. Okay. We discussed crust is 0 to 60 kilometer. Plate is what? Lithosphere. Okay. Lithosphere 0 to 100 kilometer. That is lithosphere. Yeah. So lithosphere is divided into several plates. We discussed lithosphere is not continuous block. Crust is only what? Upper 60 kilometer. Oceanic crust and continental crust, or we have divided into what? Upper crust and lower crust. Remember Conrad discontinuity between upper crust and lower crust. Okay, so crust is different. Plates is total lithospheric plate. Okay, so when we are talking about entire lithosphere, then we are calling it as what? Plate. When we are only talking about above part, then we are talking about crust.
Okay, so when we say plate is moving, we say asthenosphere on which
plate is moving on asthenosphere.
Okay, so when asthenosphere is moving, we say a plate is moving.
Asthenosphere is not moving. Plate is moving over asthenosphere. Okay. Asthenosphere is like this. Plate is moving over what? Asthenosphere. Why plate is able to move over asthenosphere? Because it is in plastic state, doesn't provide much friction. So that's why plate is able to move. Clear? But for continent to move means entire continent will move means what? Entire continent crust has to move. That means because continent is made up of what? Continental crust. So this entire crust has to move. But this entire crust are lighter in nature than what? Oceanic crust. So they can't break the oceanic crust and move. No? That's why see continent are not moving. We discussed which theory is fourth one. Which theory we have written fourth one? It is called as a sea floor spreading. It is sea that is spreading. Okay, it is sea that is spreading. Let's say this is how, okay, this is how continents are there. So continents are not moving. It's sea. When sea becomes more widened, then what will happen? You see continents will move away. So it is the sea floor that is spreading, not the continent that is moving, because it is not possible to move the continent. Clear? Because continental crust are what? Lighter in nature, they can't break the oceanic crust. It is the sea that is okay widening, and when sea will widen, what will happen? Continent will move apart. Clear? So drifting of continent is not happening because continent moving. Drifting of continent is happening because sea is spreading now, which is taking away continent to different places. Clear? Any doubt regarding this one? So that is why later theory, as we discussed, this question was arose that that how can continent move, because continent are lighter in nature, these crusts are lighter in nature, they can't break the oceanic crust. Okay, so they can't move. So that's why the question arose like this, and that's why what had happened, we discussed later on, sea floor spreading theory came to explain that no, continent is not moving, rather sea is moving. Clear? Any doubt regarding this particular thing?
Content of crust matter. Complete this part is more.
No, continental crust. Crust is only we are talking about 0 to 60 kilometer. It will encounter ocean plate. When it is moving, it is encountering which plate? It is encountering which crust? Oceanic crust. Now this is a continental crust. This is a oceanic crust. Clear? Like I'll make a diagram.
So include plate in it as well.
See, this is okay, continental crust. This is a continental crust. Now this part is what? Water, and this is okay, what we call as a oceanic crust. Okay, this is a continental crust, this part is a oceanic crust. This is plate. This whole solid part is a plate. This whole solid part is a plate. Clear? Any doubt regarding this one? So we discussed crust is only how much? 0 to 60, while the plate is how much? Around 100 kilometer lithospheric plate. Okay, so lithosphere is extending by around 0 to 100 kilometer. Clear? Now we discuss this lithosphere is divided into what? This lithosphere is divided into what? Many plates. It is not a continuous block. This lithosphere is divided into many plates. So you can have a continental plate also. You can have a oceanic plates also. That is okay there. Clear? So this lithosphere is divided into many plates. Now when this crust is trying to move, it is encountering, which is okay, encountering oceanic crust. Now this is more heavier. This is more heavier. Continental crust can't move oceanic crust. If they have to drift from here to here, they have to also take oceanic crust along with them. No, then only what will happen? Oceanic crust also has to move from here to here. So can continental crust can push the oceanic crust? No, because this is lighter in nature. Oceanic crust can push a continental crust because these are heavier. You can push the heavy. Okay, if you have a more strength, you can push. Okay, what? The lesser, okay, what? Lesser strength person. But if you have okay more, okay, what? Less strength, then how can you pull? Okay, the rest. Okay, the more strength person. No. So that's why what is happening is for continent to drift, they have to what? They have to nothing but okay, what? Move this particular thing. But oceanic crust can move. Okay, oceanic crust can push. Okay, what? Continental crust. This is what sea flow spreading is saying, that it is ocean moving. When ocean will move, ocean can push the continental crust because these are lighter in nature. Any doubt regarding this?
So when we say the green line is moving, so either the plate is moving or the oceanic.
We are not saying great F. We are saying that faulting is happening. Fault means what? Normal fault and reverse fault. So block is being created, rupture is being created. Now this rupture has created a rift valley, and this is created what we call as a block mountain. Now okay, what will happen is okay, now is okay, what? This is now spreading. Okay, this block, the first okay, what had happened? Faulting had happened. Faulting has created what? Rupture, and this faulting has created nothing but okay, block mountain as well as other part. Okay, now what is happening is okay, what? This particular rift part is widening. This particular rift part is something that is okay, widening. Clear? So this rift part is widening because of what? As we discussed, what is the reason? You see, okay, what will happen? Volcanic eruption. New okay, what? New material will come out and older material will move away. Older material will move away, new material will come out. This is reason for formation of what? New crust. So that's why it is widening. So here continent is not moving. What is responsible for movement? Rift valley means what? Water is there, no? So it is okay where the things are okay spreading.
So but it is said though that part will be broken. It is going to be broken.
Huh.
So it is along the crust only.
Yeah.
That the rift occurred and it is going to break.
Yeah.
But when that part will start moving, it will either be because of a plate movement.
Plate movement. Plate movement as a
whole. Or the oceanic crust will
Continental crust, yes. Okay, so we discussed, okay, what is happening, okay, in case of, okay, Atlantic Ocean widening, Pacific Ocean, what is happening, shrinking. So okay, entire plate is something that is, okay, moving. Here we are only not talking about plate, because plate tectonics, when we'll come to plate tectonics, then we'll talk about what, plate. Currently only we are talking about which theory. Currently we are only talking about nothing but, okay, Wegener's theory, Wegener's criticism. Wegener is not talking about concept of plate itself. Wegener is talking about what, crust. Wegener is talking about what, crust. We are not talking about plate right now, because plate comes when we'll come to plate tectonics theory. Wegener is only talking about what, crust. And we know that continental crust is made up of which type of rock, felsic. Oceanic crust is made up of which type of rock, mafic. Since oceanic crust is more denser, okay, it is more heavier. Continental crust cannot move, okay, the oceanic crust. That's why it is not possible for drifting of continent. Clear? So that is, okay, another criticism that has been pointed out. Okay, we'll stop today. Rest will take up in the next class. Okay, so other criticism and other theories will start in the next class. Fine. Anyone having any doubt? So clear, any doubt regarding till now regarding Wegener's theory?
Means both are laid in the above the both are laid above the
They are part of lithosphere. Lithosphere means what? 0 to 100 kilometer. And when you take 0 to 60, what is happening? Crust. So they are part of lithosphere only. Okay, they are not lying above the lithosphere. They are part of what? Lithosphere only. Fine. We'll discuss again tomorrow. If you have any doubt, we'll clear it tomorrow.
Thank you.